Okay, this is the second lesson, second lecture, after the one that we covered about global air circulation. The reason why we covered especially the first part about global air circulation was to make sure that you understand where our mid-latitudes and also our tropical cyclone and subtropical anticyclones are derived from. So now we are moving on to mid-latitude cyclones. I'm just going to sum it up as well so that at least you prepare yourself for the prelims or for the exams that you are going to start this coming week. So mid-latitude, what is it that you need to know? The first thing, you need to know where they originate from. You need to know where they originate from. I think from the diagram that I used to explain when I was doing explaining the global air circulation, I showed you the subpolar high, which is where our L is. This is an area, it's a low pressure belt. So subpolar low is also not subpolar high, subpolar low, which is a low pressure belt. What we have within this region, okay, we are calling it a mid latitude because of where it happens. It's in the mid of latitudes. Okay, that is where you have got your subpolar. That is where you have got also have your subpolar. Then here you've got your polar subtropical high as well. So here is in between. That's why we refer to as the mid latitude. We have got a low subpolar low, and this is what is separating the polar easterlies and the tropical easterlies. It is separated by the polar front. Why? Because these two air masses, they've got different characteristics, like I've already highlighted, in terms of their moisture content, in terms of their temperature. Hence, they cannot mix. Why? Because they've got two different characteristics. If I were to take you back to grade 11 about air masses, I'm not going to get deep into that, but basically, two air masses, different characteristics. Where are they coming from? Are they coming from land towards the sea, or from the sea towards the land? That's where they derive their names, but however, I'm not going to get into that. So we've got the polar easterlies and the tropical westerlies. These two does not meet. This is the northern hemisphere, but I'm going to focus more on the southern hemisphere where we are. Okay, so we've got the tropical westerlies and then polar easterlies. Okay, same applies. These two does not meet. As you can see here, I'm going to use this one. I'm going to explain the stages, but I'm just going to say one or two things about some of the characteristics of mid-latitudes. The first thing is we need to know where do they originate from. They originate when warm tropical westerly winds meet the the polar easterlies winds. Okay, so this is what we are saying. This is where they originate when the tropical westerlies meet the polar easterlies. This is where they originate from. That's what you need to know. The mid-latitudes, where do they originate? When the tropical westerlies meet the polar easterlies. In the southern hemisphere, the tropical westerlies meet the polar easterlies, but the two do not mix. They are separated by a polar front. This is where they originate. This is the first thing that you need to know. You also need to know the alternative names. You can be assessed. They can talk about, they can assess, give you an assessment where they are using a different name other than the mid-latitude, such as the temperate cyclones, frontal depressions, extratropical cyclones. These are the other alternative names for the mid-latitude. Like I've said, the temperate cyclones, the frontal depressions, and the extratropical cyclones. These are the other alternative names. You need to know about that as well. What are some of the general characteristics? What are some of the general characteristics of the mid-latitude cyclones? I'm just going to highlight some of the general characteristics of the mid-latitude cyclones. We are looking at they occur between 30 degrees and 60 degrees north and south of the equator. They occur between 30 degrees. Remember, here is our 0. There is our 30 degrees north. There is our 30 degrees south. There is our 60 degrees south. There is our 60 degrees north. So you can be asked in terms of their location. Where are they located? They occur between 30 degrees north and south of latitude. Okay, this is the 30 degrees north and south latitude. This is where they're taking place. This is where your polar front is. So this is where they are occurring. This is where they are occurring. That is between your 30 degrees north and 30 degrees south. This is where you've got your mid-latitudes. That's why they are called mid-latitude. They occur between the 30 degrees north and 6 north and south of the equator. They move from west to east. They move from west to east. They move from west to east in terms of their movement. They move from west to east or eastwards. They move from west to east or eastwards As you can see, you are going to see when I'm going to explain the stages, you can see from here, they're going towards east, you can see. That's basically what you're talking about. So in terms of their movement, they move from west to east, okay? Or they move eastwards, okay? They are steered by the westerlies in the westerly wind belt. They are steered, which means this is what help them in terms of their formation and movement as well. They are steered by the westerlies. Where are we getting our westerlies? Our westerlies, we are getting it here. Remember, from between 0 to 30, we have got the easterlies. We have got the easterlies here, easterlies there. Then here we have got the westerlies. So this is what steered. This is what steered the mid-latitude, okay? Because they are happening within the 30 degrees north and south pressure belt, okay? So here, that's where we have got the westerlies. So they are steered by the westerlies. Why? Because of where they happen, okay? This is the westerlies. Here we've got the easterlies. Here we've got the easterlies. We've got the easterlies, you've got the westerlies, you've got the easterlies. So they are steered. You see the region in which they we find them. They are located 30 degrees north to 60, 30 degrees south to 60 degrees south. So they are steered by them westerlies. Okay. Temperate cyclones consist of fronts. They consist of fronts. That is the warm and the cold fronts. I'm going to use it when I'll be explaining the different stages. Okay. Then what else? They vary. Large cyclones with a diameter of about 1,000 kilometers. That is the diameter. Know the diameter as well. It can be assessed on the match and the multiple choice question. The diameter of 1,000 kilometers. What else? Okay, throughout the year, but affects South Africa mainly in winter. It occurs throughout the year, but it only affects the South Africa only in winter. Why? Because they move. When they are close now to Cape Town, that's where, you know, it affects South African weather. When they move downwards, obviously, they won't be close to South Africa. That will be summer in South Africa, then they won't have any effect. But it happens the whole year. Okay, so what it only affects South Africa in winter is because of movement. It would have moved downwards, okay. Then also, it lasts between 4 to 14 days. 4 to 14 days. It lasts between 4 to 14 days. So you need to know the diameter. We've talked about 1,000 kilometers. How it lasts is 4 to 14 days. It's also very important. Then from there, what are some of the conditions that are necessary for its formation? The first thing is there's supposed to be the warm air from the subtropical high and also the cold air from the polar high. That's one of the conditions that is supposed to be there. Remember, these two meet, but they are separated by a polar front. So we need to have those two different air masses. Then what else also is needed? Both air masses, they move parallel to each other. These air masses, we have got our easterly, we have got our westerly, they move parallel to each other. That's another condition that is necessary when it comes to mid-latitude. What else is necessary? The frictional drag between air masses causes they interact with each other. Okay, this is what results in the stages that I'm moving to now. The stages in the formation of mid-latitude. What is it that takes place? As you can see, the first thing is, I'll also try to be as loud as possible because I can feel like I'm not audible enough. Okay, the initial stage. This is your initial stage. What do we have? We have got your cold polar air. Then you've got your warm that is coming from the subtropical. So this is warm. I'll say W. This is cold. Okay. So these are the two air masses that we have, and they are separated by a polar front. Warm tropical air from 30 degrees south and cold air from 90 degrees south converge at the polar front. So these two are converging at the polar front. This is where we've got our polar front subtropical low. That's where they are converging. This is the initial stage. What else is happening here? Coriolis force deflects both air masses in the southern hemisphere towards the left, causing them to move parallel to each other in the opposite direction. We are talking as in the left because we are referring more in the southern hemisphere. That's why we are saying Coriolis force is pushing towards the left, because we are more concerned with here. This is where we are in the southern hemisphere. Remember, we said Coriolis force deflects the wind to the right in the northern hemisphere and left in the southern hemisphere. That's why we are mentioning the left. That is your initial stage. So here, you have got your 60 degrees south, that is your subpolar low. Then you have got here, is coming from the subtropical, that is your warm air. This is coming from the polar high, that is your easterly, that is cold. So these two air masses, they've got different characteristics. They are not going to mix. Why? Because they are separated by a front. Instead, this one is undercut, the warm air is undercut by the cold air, which causes to rise, hence creating low pressure, as you can see. So here, there is low pressure that is created, okay? Okay, that's stage 2. Wave formation. This is the wave formation. Stage 2, what is it that is taking place there? The wave stage occurs when the frictional drag takes place between the two air masses. A wedge of warm air begins to be uplifted by the cold air. Fronts begin to form. The air converges in the clockwise direction, southern hemisphere, towards the low pressure. So we are now saying that there is the formation of low pressure now. We have got now our cold front starting to form here. Then we also have our warm front, but it's not yet well defined, but there is low pressure. This is your wave formation now, because now the warm air is undercut by the cold. Then we have got formation of the cold. You can see the direction in which it's moving. It is mostly affected by the westerlies, like we say. Now it has reached the mature stage. It has reached now the mature stage. This is now the mature stage that it has reached. Now we have got clearly defined cold and warm front. We have clearly defined cold and warm front. How do you identify the two? Cold front, obviously, you can see with these triangles. Then your warm front, you can see with the semicircles that you can see there. So behind the cold front, which is the CF, we have got cold air. And in between there, in front of the cold front, we have got the warm air or the warm sector. Then we have got the warm front. And behind the warm front, we have got the warm air, which is part of the warm sector. Then ahead, you have got the cold. Okay, so what happened is the isobars behind your cold front, they are very close to each other, which depicts a high pressure gradient. It means that we have got strong winds. This is what is helping in driving the mid-latitude cyclones or the front of depression. We have got isobars that are close to each other behind the cold front, which means that the winds are strong, high pressure gradient, which means there are strong winds there. Then as ahead here, where we have got our warm sector, we have got now, this is where we have got development of the clouds, mostly the cumulonimbus. Then we have got rainfall. But where we have got our warm front, mostly we can have little no rainfall, drizzle-like, maybe from stratus clouds that form there. We do not have a lot of rainfall. So you need to understand mostly the mature stage is very important. How to interpret it. Behind the cold front, what we have got cold air. Ahead of the cold front, we have got the warm sector, there's warm air. Behind the warm front, we have got warm air. Ahead of the warm front, we have got cold. But however, you see that the isobars are further apart. Where we have got our warm front, then here where we have got our cold front, they are close to each other, which depicts steep pressure gradient. That means that there is strong winds behind the cold front, which helps in movement of our front. There's cold air. There's the cold sector. Ahead of it, there's warm air. There's formation of clouds of vertical extent like cumulonimbus, which results in heavy rainfall that can result also in floods. That's why we usually have floods in Cape Town during winter. Then from there, as we go to our warm front, behind it, warm air. Then we can also have some clouds here. We can also have some clouds here, stratus clouds, drizzle, light rainfall. Then we have got cold air just ahead of our warm front. So basically, this is our mature. Then lastly, what we have now, this cold front and the warm air is now been merged. They have now been occluded or joined, giving us what we call an occluded front. Okay, so we have got the initial wave formation, mature stage, then you've got an occluded stage. That's what we have. These are the stages that we have in as far as the mid-latitude is concerned. But however, there's something I also need to emphasize. Okay. You can also be asked about an occluded cold front and occluded warm front. I need to highlight also the difference between the two. Okay. This is our cold front. This is our warm front. So when you talk about the occluded cold front now, the cold front will have to touch the surface, as you can see. This is our cold front. Let me just show it. This is a cold front. This is our warm front. So when the cold front touches the surface like this, the edge of our cold front, this is an occluded cold front. What do we have? We have cold air, then we have got warm, then we have got cold air, like I've already explained. This is an occluded. Obviously, this one is going to be associated more with the same condition that we talked when we are talking about the mature stage. Obviously, there is more formation of cumulonimbus clouds, clouds of vertical extent. Behind it, there are stronger winds because there's a steeper pressure gradient. So our cold front touches the earth surface, okay, touches the surface. That's what we get as the occluded cold front, okay? You can see here, it touches the surface. You can see this is where it touches the surface. But when you're not talking about our warm occlusion front, which means our warm now, what does it do now? It also touches the surface. Then we have got this is our cold front. This is our cold front. But the difference now is the warm front is touching the surface. That's why we have got our occluded warm front. This is the major difference between the two. And normally also when we talk about the cross section, obviously we are going to have something like this. This is a occluded cold front, occluded warm front. Let me just draw a diagram of the cross section. Diagram of the cross section is more or less, okay, it's more or less like our mature stage. I would say this is, okay, obviously this is our cold front, and we have got our warm front going the other way around, okay, from the earthy surface. Okay, let me put it like this. This one, I'm not gonna put the symbols to denote changes. Here we have got steep pressure gradient, okay. What else do we have? We have cold air here, okay. Then here what we have? We have got the cold front. Okay. Then obviously here what we have, this is part of we have got the warm air, part of our warm sector. Then what we have got the cumulonimbus clouds, the rain there. Then here what we have behind the warm front, we have got warm air. What else do we have? We can have stratus clouds. Then here we have got cold air. So in short, it's not that clear, but in short, what we are basically saying is this is more like a cross-section of a mid-latitude cyclone. This is more like a cross-section of a mid-latitude cyclone, where we have got the steep pressure gradient behind the cold front, we have got the cold air behind the cold front, we have got the warm air, then we have got the cumulonimbus clouds, rainfall, stratus clouds here, which is little or no rainfall. As we have it, we have got our warm front, then we have got cold front. That is our cold air. That is the cross section of our mid-latitude. So some of the questions that can be asked are what some of the impacts of the tropical cyclones. Usually is associated with heavy rain, especially in Cape Town in winter. It's associated with heavy rain. Obviously, the floods in the environment. You see that there's disturbance in terms of the destruction of animal habitats, natural, okay. Our biodiversity is also affected in a way. There's soil erosion that takes place. That is part of the environment. So you need to know some of the impact, the economic, social, and also economic impact. But mostly what has been assessed, I think for the past 2 years, it has been the impacts, especially on the environment, of which you need to know how also the vegetation is destroyed, biodiversity, how soil erosion is also land degradation. You look at all those things as some of the impacts of mid-latitude cyclones, because usually they are associated with heavy rainfall. So you need to know about what are some of the impacts, and also what are some of the measures that can be put in place in order to make sure that we protect people against such impacts. So when it comes to geography in general, we identify the problem, we analyze the problem, then we also look for the solution to the problems. So you need to be also aware of that. So mid-latitude in general, I think we have talked about it in form of a summary. Where is it located? Mid-latitude, that is between your 30 degrees north and south, 30 degrees to 60 degrees north and south of the equator. In the mid, that's why it refers to as the mid-latitude. What happens in the 30 degrees north and south of the equator, like I've already highlighted, you'll find that in the mid, like I've already highlighted, you'd see that there are two air masses. That is your easterlies from the polar, and your westerlies from the subtropical. That do not meet, that are separated by a polar front. And you can see with the stages that I've taken you through, the initial stage, the wave formation, mature stage, and the occluded stage. I've explained that. I've also explained about the occluded cold front and the occluded warm front, and also the cross section is very important. The main impacts that we cut from the mid-latitude cyclones, mostly we have got the floods, we have got those winds that are coming out, mostly the heavy winds that result in the negative impact, especially on the environment. There can also be displacement of natural wildlife, also as a result of the strong winds, of the floods as well, destruction of habitats, soil erosion, land degradation. Socially, you can see there's a displacement of people, especially in those areas that are affected by floods. You can also, the source of income, some people cannot go to work for that time when there are floods. So these are some of the impacts. And also, we need also to make sure that we have got early warning system to tell people that there's likely to be floods coming. We also need to make sure that people, they stay also on highland areas so that they are not affected by the floods. So in general, this is all about mid-latitude. If you can watch this clip, if you have got any questions, please leave a comment.